So thanks for coming back. And I hope while your video was paused that you marked up this graph on hospitalization. So this starts at the very beginning of the pandemic and goes all the way through the end of August. And I actually am going to have you pause the video in a minute and try these questions on your own. But I just want to point out to you, as you drew these tangent lines all over the place, I hope you recognize where the couple are the flattest. I think the very, very flattest one we have is this one right on the top. Okay. And then where do we have our steepest, right? And you can see where I've labeled that. So please pause the video now and try these questions on your own before restarting the video. So try the questions associated with number 9 and then come back. Okay, so if you came back after trying these on your own, go to that very, very steepest line and put your ruler and see, where am I touching the curve? And notice it's way down in here. There is a spot, and again, it might just be due to not enough detail in the graph. It almost looks kind of linear in here, doesn't it? As I put my ruler along, you know, we almost have a point where it's going up pretty steadily, okay? But the steepest that this graph ever is where I'm touching the curve. So it's not right at the beginning of the pandemic. Right at the beginning of the pandemic, notice it's a little flatter, right? Then it gets steeper here. It does get steeper. That's not the steepest that it ever is, though. The steepest that it ever gets is right around in here. Okay, so right around where I've got these arrows, which if I look at this, the steepest point of the graph is around in the April 18th range. So think back to last spring, right? In early April, that's where the lockdowns really took hold. Okay, so the curve was still getting steeper and steeper through the early part of April. But then right in here is about where we turn the corner, so to speak. Notice how this gets a little flatter. If I'm right here at about April 18th, notice my ruler's not lined up with the steepest, right? If I'm touching the curve right about April 18th, okay? Which is why I have that labeled as my inflection point. Now, you might differ a little bit. This is not a super accurate way to find an inflection point. I always tell my Calc 1 students, inflection points are just not things you can eyeball very accurately. Okay, and in Calc 2 or in Calc 1, we have a very precise formula method for finding inflection points. Okay, they are hard to eyeball, but it's somewhere in here because we go from our steepest point to a point where we start getting flatter. Okay, then other questions here. So let's see, put an X. All right, so that is where we first, actually I put an I guess the directions say put an X, right? So put an X, and this is where we first flatten the curve. So around mid-April, we first flatten the curve. But then we get flatter and flatter, and notice our steepest point, we never again, even in the summer when cases went way, way up, this graph takes us all the way through summer. And you probably remember hearing that on the news. The cases were going up and up and up and up all summer long. And we see that here. But what's interesting is we never are as steep. The tangent lines are at their steepest down here early in the pandemic, right? In early April, these tangent lines are as steep as they're ever going to be. Even though cases were going up and up and up and up in the summer, right? Our curve is flatter than it was down here. Okay, so that's what's interesting. So up here, you know, this is early in the summer, we're concerned, right? But this is the flattest point along this graph. So the caseload is higher than it was down here, right? We have more people hospitalized, and yet we have a flatter curve. Okay, so that's kind of, I don't know if that does, think about how that settles with your intuition. Even though we have more people hospitalized, we have a flatter curve, which means that hospitalizations are high. We don't like that, but they're going up by little less and a little less every day. Whereas down here, we didn't have as many hospitalizations, but like every day we had like larger and larger increases of people coming to the hospital. Okay, so what starts to happen, I think, is hospitals got better prepared, right? And then our curve was flatter, all right? So we were better able to handle more people coming to the hospital than we were early in the pandemic. In the summer, we can see, and here's where I put the sad face, this is the steepest point in the summer, right here. It's still not anywhere near as steep as what it was early in the pandemic, okay? And then finally, by the end of summer, because we know early in the fall, caseloads did fall, right? Early in the fall, by the end of August, early September, they were falling. And it shouldn't surprise me then, the flattest point I ever see is right at the end of August, all right? Because caseloads are actually getting ready to fall over here. So the curve gets very flat before it would do this and caseloads would fall. So based on what we've seen so far, you are probably thinking concave up, right? Like right in here is concave up, right? I can see it, okay? You're probably thinking concave up, bad, concave down. We're clearly concave down here. Concave down, good, right? That's probably your thought. Concave up, bad, concave down, good, okay? But hold that thought for a minute. We're concave down here. We do go concave up very briefly right in here, then concave down again. Okay, so let's look at what happens when a set of data is decreasing, and let's look at what that means as far as concavity. And in order to model this well for you, I'm going to draw a number line up here. Okay, so you already have a graph for number 5. And let's take a look at the first rate of change. Okay, so here, how do I get from 20 to 19? I add -1, then I add -2, add -3, and you might be tempted to say that's increasing, right? 1 to 5, but remember it's negative. So if I start at -1 and I go down to -5, if I move left on my number line, I'm decreasing. Okay, so right here, my first rate of change is decreasing. Okay, my second rate of change, how do I go from -1 to -2? Right, look on the number line, I add a -1. How do I go from -2 to -3? I add a -1. So notice my second rate of change is negative. Decreasing and then negative did go together on the other page as well. And then over here, I go by -5, -4, add -3 to 11 to get 8. -2. Again, you might say, oh, that's getting smaller, 5 to 1. But remember, we're going this way on the number line, -5 to -1. We are actually increasing. And then our second rate of change, I would add 1 to get from -5 to -4. And then I would add 1 to get from -4 to -3. Okay, so my second rate of change is positive. So we see the same thing with the decreasing function that we did when the function was increasing, that if the first rate of change is decreasing, right, then my curve is concave down. Okay, because the first set of data I graphed it right here. This is data set A, the top curve, and this is data set B. Okay, I graphed these on the same set of axes. So this is concave down, right? Down like a frown, and then up like a cup for set B. Okay, so a decreasing rate of change, a decreasing slope always means that my curve is going to be concave down. Okay, so the one that is concave down is data set. Oh, I have a typo here. Let's see. Which one's concave up? Set B. I better change this before I print it for you. Okay, so which one's concave down? So set A. Concave up, set B. Okay, so then we're going to look at acceleration. Okay, and where is the virus caseload accelerating? Okay, and when the virus is increasing, this is very intuitive. When the graph is increasing and the slope is increasing. And remember, that happened where we were concave up, right? So I could draw the picture, right? It looks like this. That's where the caseload is accelerating. Very increasing, right? Or very intuitive, increasing at an increasing rate, and thus intuitive. Okay, but what we're going to look at is when the graph is decreasing, how do we see acceleration there? Okay, and so let's actually go over to the second graph that I give you, which is going through the whole pandemic to where we are at our present time, which luckily our caseload is on the decline, and we hope it stays on the decline thanks to the vaccine. Okay, but anyway, let's look at this section where it's decreasing. All right, and what I want you to do is pause the video for a moment, put your ruler along here, and draw a bunch of tangent lines. All right, and look at where it's flat, where's the tangent lines the steepest? And where are they flatter? Okay, and so clearly, if I were to talk about concavity, I can look right in here and say, clearly I'm concave down, but then like right in here, notice right in here, I'm definitely concave up. Okay, I have an inflection point in here somewhere. Not sure if it's like here or here. It's like I said, it's hard to eyeball, but somewhere in here, I go from concave down to concave up. Okay, so this is where we should not say, oh, concave up is bad and concave down is good, right? Because right here I'm concave down, and I'm actually going to be happier about life. Okay, but you pause the video and draw a bunch of tangent lines. Okay, if you're back, let's find the steepest versus the flattest of these lines. Okay, and the steepest is right here. And the flattest is over here. And since I'm decreasing, I don't want my curve to be flatter. I want it to be steeper, right? Because the virus is decreasing. And so if you have been following the news, not too long after Christmas, like if I line this up, the steepest point is right about here, right? Right after we had started declining, we were declining very quickly, okay? But then as we continue to decline, the curve actually flattens again, okay? By where we are today, or as of maybe a week ago when this graph was printed, right? This is flatter. But so what that means is that the virus is declining, but we were declining at a faster rate up here than we are down here. All right, the curve has flattened, but when we're decreasing, we want it to be the opposite. We want a steep curve and not a flat curve, okay, for decreasing. And that has to do with acceleration. Okay, so before I go back and fill in that, let's just see, can you find the inflection point? So I think it's somewhere around in here. All right, and why am I not happy about getting to an inflection point, right? We wanted an inflection point when we were trying to flatten the curve, right? When cases were going up. Now I get an inflection point, the curve's flatter, I'm not happy. Okay, and this all has to do with acceleration. So I'll let you put that in your own words. And let me go back here and fill this in. When a graph is decreasing and the slope is decreasing. But remember, when we were decreasing, when we had a decreasing slope, it grew in absolute value. It grew in magnitude. Right? The absolute value of that slope is greater. All right. And so that idea is at play down here. The slope is increasing, but what that really means is that it's growing in magnitude. Okay. So, which makes it steeper. All right, because the more negative it is, the steeper it is. Okay, the line is steeper, right? The slope is, and I'm going to put this in quotes, more negative, because that actually does not have actual mathematical meaning. Okay, but it's got larger magnitude. So this might feel a little counterintuitive, right? That I'm saying the graph is decreasing, the slope is decreasing, therefore I'm accelerating, right? But the slope, when it gets more negative, it makes the line steeper, right? And that's where we see acceleration. So anyway, let's just finish up a couple things here together. So it talks about from Memorial Day until the summer peak, find the inflection point. And what's interesting in that part of time, if I could magnify this curve, it looks a little bit like this, like we're concave up, right, going into summer. Very briefly, early in summer, we go concave down for just a minute. Okay, so we do have an inflection point, like right in here. But then we actually will have another inflection point where we go back to concave up. Okay, because right into here, right leading into the summer peak, we are concave down. Okay, but we are very briefly, I'm sorry, we're concave up going into the summer peak. Right here, we're very briefly concave down. So you would have an inflection point the moment that I change from concave up to concave down. The moment I start flattening those tangent lines, right? This would be the steepest tangent line for this period. Now the tangent lines get flatter. That's the inflection point. Okay, then question B says, from Labor Day until the week before Thanksgiving, is the graph concave up or concave down? So right in here. And what does that mean? Okay, and we all, if you were watching the news in the fall, they were very pessimistic about where we were, and this is going to be the darkest period in history for American public health, right? We are concave up here. The virus is increasing at an increasing rate, okay? We have steeper tangent lines like right in here. My tangent line, let's see how that compares to even at the beginning of the pandemic. Right? So at the beginning of the pandemic, when we were shutting things down and saying flatten the curve, this line's way steeper, right? So this is what was happening to us through the fall. That's why public health officials were very concerned and begging us not to gather at Thanksgiving and Christmas. Some of these dips that you see in the curve around Thanksgiving and Christmas due to labs being closed and not testing, right? That's why we see some of these dips before the caseload rises again. We do right before Thanksgiving. You can see right in here, we flatten the curve a little bit going into Thanksgiving, right? So look at that. This tangent line right here, right before Thanksgiving, right, is much flatter. Okay, so we are concave down just the maybe week or so before Thanksgiving. Okay, so I hope you found this lesson to be interesting and informative, and I hope this gave you a new look at how to analyze data that you see in the news, how to read these graphs, and what it really does mean to flatten the curve. Thanks for joining me here.